Okay, let's take a look at sigma notation, or what's called summation notation. Now the notation looks a little odd, looks like this. First of all, this what looks like a backwards E is actually the Greek letter sigma. And the way you say this is this. This would be the summation of the constant 3 as I goes from 1 to 4. So you've got a lower bound of 1, you have an upper bound of 4, and that tells you how many times you're going to add this thing together. So it's fairly easy to do. What we'll do is this, is the summation of the constant 3 as I goes from 1 to 4 would be the following. All you do is when I is equal to 1, you've got a 3. When I is equal to 2, you've got another 3. When I is equal to 3, you've got a 3. And when I is equal to 4, you've got a 3. And if you add those up, 3 plus 3 plus 3 plus 3 would give you 12. And all you're doing here is this. This is where I is equal to 1, I is equal to 2, I is equal to 3, and I is equal to 4. So you just add it up four times and you've got the answer. Let's take a look at another one. Exactly the same problem, but rather than adding it up 4 times, we'll add it up 7 times. So from I goes from 1 to 7. So this would be I is equal to 1, plus I is equal to 2, plus I is equal to 3, plus I is equal to 4, I is equal to 5, I is equal to 6, and I is equal to 7. So what I wind up with is 7 3's. If I add all that up, I'll get 21 for a final answer. So 12 was the first answer, 21 is the second answer. So what you've got here altogether, you did this thing 7 times, so you wound up with 7 of these things. So 7 of them from there to there. Now you can come up with a formula for that. Later on it'll actually turn out to be this. Since you're just adding the constant up n times, this will actually turn into the formula C times n that we'll use later on. So there's a couple of examples just adding up a constant. Now let's take a look at a couple of other things. Okay, now you don't just have to add up a constant. You can put the I inside the function, but it's still a process is going to be the same thing. We're going to add this up from 1 to 4. So what this is going to be would be when I is equal to 1, you would have 2 times 1. Now in these kind of problems, if you've got an I, you substitute I with what it's equal to. And you're going to add that to, this would be 2 times I is equal to 2, plus 2 times I is equal to 3, and then finally plus 2 times I is equal to 4. So what you've got there, this was where I was equal to 1, I is equal to 2, I is equal to 3, and finally I is equal to 4. Well, now add those up, and what you come up with, this first one would be 2 plus 4 plus 6 plus 8, and if you add it all up, you'd have 10 plus 10, this would be 20 for a final sum. So again, if it's got an I in it right here, just everywhere you've got an I, substitute what I is equal to as you go across there. Let's try this one. We've got I plus 2 as I goes from 1 to 3. And I'm going to put them in parentheses here. So this is going to be 1 plus 2, so where I is equal to 1, plus, now on this one, I would be equal to 2, so it'll be 2 plus 2. And then on this one, I would be equal to 3, so it'll be 3 plus 2. So again, as you go across there, just remember this is where I is equal to 1, I is equal to 2, and I is equal to 3. Well, now add those together. First of all, 1 plus 2, this will turn into a 3, plus 2 plus 2 would be a 4, and finally 3 plus 2 would be a 5. So you wind up with 7 plus 5, which would be 12. And they get a little bit more complicated. Let's take a look at each one of these, and we'll do them exactly the same way. Now what I'm going to do here is just I'm going to get 4 separate terms. So I equals 1, 2, 3, 4. So just everywhere you've got an I, plug in what it's equal to at that time. So this is going to be 2 times 1 plus 1. There's the first term. Plus, second one would be 2 times I is equal to 2 plus 1. Add the third one, 2, and this time I is equal to 3 plus 1. And then finally add the fourth one, 2, and plug in a 4 for I, plus 1. Now just add all those up separately. So what this is going to be is 2 plus 1, this would be a 3. Then you've got plus 4 plus 1, this one's going to be 5. Then plus 6 plus 1, this one would be 7. And finally plus 8 plus 1, this one would be 9. Add those up and you'll have the final answer. So this would be 10, 19, 24. So you'll have 24 right here. So again, just let I equal 1, I equal 2, I equal 3, and I equal 4. Now finally, just a last example to show you that you don't always have to start at 1. In this case, it's going to start at 3. So you're going to go I equals 3, 4, and 5. So when I is equal to 3, you'd have 2 times 3. There's the first term. And you're going to add that to 2 times 4. Then you're going to add that to 2 times 5. And if you did this, this would be equal to 6 plus 8 plus 10, which would be 24, and there's that one. So again, just remember, this is where I is equal to 3, I is equal to 4, and I is equal to 5. All right. Now for the next example, they can be a little bit more complicated. The I could show up more than once. Let's go ahead and try this one. So what this one's going to be, and again, you're going to have 3 terms altogether. So for my 3 terms, when I is equal to 1, I would have this. I'll put the whole thing in parentheses. 2 times 1 squared plus 3 times 1. So everywhere you've got an I, plug in a 1. So that's where I is equal to 1. Then you're going to add this to 2 times this time I is equal to 2. So 2 squared plus 3 times 2. That's where I is equal to 2. And then finally, add a third term in there. So 2 times 3 squared plus 3 times 3. So everywhere you've got an I, plug in whatever the term is at this time. Now what this one's going to be, this would be 2 plus 3. So this will turn into a 2 plus 3. And then you're going to add that to, this would be 4 times 2 would be 8 plus 6. And then you're going to add that to, 3 squared is 9 times 2 is 18 plus 9. So that will turn into 5 plus 14 plus 27. And for a final answer, then add those together and you would get a 46. So again, just everywhere you've got an I, plug in whatever I happens to be at that time. In this case, you go from 1 to 3, so you've got 3 terms, and it looks like that. Now what these are all based on all the problems that we've done so far have a small upper limit. So the upper limit on this problem was a 3. But let's suppose this. Suppose rather than a 3, suppose that upper limit had been a 30. Then that means you would have to put a total of 30 terms out here. It'd take forever to do it. So a quicker way of doing these things when they have a large upper bound is to use the summation formulas. And let's take a look at those. Okay, what summation formulas are, it's just the summation of a constant, and you have actually 4 of them are all the ones we're going to look at. So the summation of a constant as I goes from 1 to n is the constant times n. Then the summation of I as I goes from 1 to n is n times n plus 1 divided by 2. Then the summation of I squared and the summation of I cubed. So what we'll do is use these formulas to solve summation problems, but without having to add up a full 30 terms or 40 terms. It speeds things up a little bit. So with this in mind, let's take a look at a couple of these and see what they look like. Okay, now the way to do summation notation is the following. First of all, we'll do this, is we'll split it up into individual sums. So what this does, this will change into, and I'm going to let this be the summation of 4I plus the summation of 2. Now, I'm not going to write the I equals 1 to 50 just to speed things up here a little bit. But if you have the summation of A plus B, and I think I'll write it up here, if you have the summation of A plus B, you can write that as the summation of A plus the summation of B. So you can split it up into two separate summations. Now the next step, once you split it up, if you've got a constant, you can bring a constant outside the summation sign. So I'll take this 4 and I'll move it to the outside. And what that's going to give me would be this. This will be 4 times the summation of I plus the summation of the constant 2. And I think I'll put those in parentheses at this point. So that one's in parentheses and that one's in parentheses. Now once you've got them down to here, go ahead and use your summation notation to change these from the I form into the N form. So let's look at the rules. You've got 4 times the summation of, and you can change this one into its I form, N form. So the summation of I is N times N plus 1 divided by 2. So with that in mind, let's do this. This will change into N times N plus 1 divided by 2. Plus, now the summation of a constant. The summation of a constant is just the constant times N. So this will turn into 2 times N. Now in our problem, what N is the top number up here. You're going to go from I equals 1 to N, so N is equal to 50. So everywhere you've got an N, go ahead and plug in a 50. So this will be 4 times, this will be 50 times 50 plus 1 divided by 2 plus 2 times 50. Something I like to do on these is anytime you get a chance to cancel something out, go ahead and cancel it out. So in this case, 2 will go into 4, so you can cancel out the 2 goes into 4 and leaves you with a 2 up here. So if you get a chance to simplify something, go ahead and simplify it as early as you can. What that's going to give you would be 2 times 50 times 51 plus, and 2 times 50 would be 100. Now, if you stick these on a calculator and multiply this one together, it will turn into 5100 plus 100. So the final answer to this problem will be 5200. But just remember, replace the summation of I, change each one of the I's into their N formulas. So that one changes into that, and this one changes into this. And then whatever N is, go ahead and plug it in. Let's take a look at another example. Okay, now to start with, we'll do exactly the same thing as we did in the last one. First of all, split it up into 3 separate summations. So this will be the summation of 2I squared plus the summation of 3I minus the summation of 5. Now the next step, if you've got a constant, you can go ahead and bring that constant outside the summation sign. So I'll bring the 2 out in front, and I'll bring the 3 out in front. So what that will give me is 2 times the summation of I squared, and I'll put parentheses around that, plus 3 times the summation of I minus the summation of 5. Now again, I'm going to go ahead and change each one of these into their n form. So summation of I squared is n times n plus 1 times 2n plus 1 divided by 6. So that's going to be n times n plus 1 times 2n plus 1, all divided by 6. And you've got plus 3, the summation of I. We'll look back at your formulas. The summation of I is n times n plus 1 divided by 2. So this will be n times n plus 1 divided by 2. And finally, you've got the summation of a constant, which is just the constant times n. So that's going to be 5 times n. Okay, now again, anytime you get a chance to cancel something out, go ahead and do it. So what I can do here is the 2 goes into here and leaves me with a 3. And now just start plugging the numbers in. Well, in this case, n was equal to 40. So the upper limit of this thing is 40. So what this would be everywhere you've got an n, plug in a 40. So this is going to be 40 times 41. And then 2 times 40 would be 80 plus 1 would be 81. The entire thing divided by 3. Then plus 3 times 40. And then plug in a 40 here. 40 plus 1 would be 41. The entire thing divided by 2. And then finally, plus 5, and plug in a 40 there, and you'll have that. Okay, now individually stick each one of these things on a calculator. If you put this term in a calculator, it will turn into 44280. If you put this term on a calculator, it will turn into 2460. And finally, 5 times 40 would be negative 200. Now just add these three terms up and you will get 46540. So 46,540. So again, start by splitting it up into 3 individual summations, bring the constant out in front, and then just replace each I thing with its rules. So that one turns into that. This one turns into this, and this one turns into this. Then, whatever n is, go ahead and plug in. Everywhere you've got an n, plug in a 40, solve it, and you got it. And let's take a look at one more. Again, sometimes you got to do a little work with them first. Let's take a look at this one. What this is going to be, before I can solve the thing, I've got to do the following. I've got to FOIL this part out, because this is like having I plus 3 times I plus 3. So this would be the summation from I equals 1 to 20 of 2I times, and when you FOIL this thing out, you would get I squared plus 6I plus 9. So this will turn into I squared plus 6I, because you have I 3 plus 3, plus, and the last term squared would be 9. So the first thing you do there is to FOIL that out. Okay, the next thing, you've got to distribute. So go ahead and distribute this. This times this, this times this, and this times this. So distribute this thing. And when you distribute it, it will turn into this. This will be the summation, again, from I equals 1 to 20 of, this would be 2I cubed plus 12I squared plus, and 2 times 9 would be 18I. So before you can apply the rules, you have to FOIL it and spread everything out. Again, like we've done before, go ahead and split this up into 3 separate summations. So this will be the summation of 2 times I cubed plus the summation of 12 times I squared plus the summation of 18I. So split it up into three separate ones. Then again, if you get a chance to, go ahead and bring the constant out in front. So I'll bring this 2 out in front, I'll bring this 12 out in front, and I'll bring this 18 out in front. So that's going to get you to 2, and I'll put them in parentheses again. This will be the summation of I cubed plus, this would be 12 times the summation of I squared plus 18 times the summation of I. The next thing, go and look and change each one back into the formula. So this would be 2 times, and again look for the I cubed formula. Well, the I cubed formula is n squared times n plus 1 squared divided by 4. So we'll make this be n squared times n plus 1 squared divided by 4. Then plus 12, and change this one into its formula. So the formula for I squared is n times n plus 1 times 2n plus 1 divided by 6. So this would be n times n plus 1 times 2n plus 1, the entire thing divided by 6. And then finally, you've got 18 times, and again the formula of the summation of I would be n times n plus 1 divided by 2. So replace this with n times n plus 1, whole thing divided by 2. Now, next step, go ahead and replace n with what it's actually equal to. So again, on this problem, just a reminder, n is the upper bound, so n is going to be equal to 20. So everywhere you've got an n, stick a 20 in there. Now you can simplify stuff on some of these if you can, so we'll take advantage of that to go ahead and simplify these a little bit. So first of all, 2 will go into 4 and leave me with a 2 down here. 6 will go into 12 and leave me with a 2 up here. And finally, 2 will go into 18 and leave me with a 9 right there. So I'll take advantage of being able to simplify these. Okay, now with that in mind, what that gives me is, in place of n squared, I'm going to have 20 squared times 20 plus 1 squared, all divided by 2. Then I'll have plus, now I've got the 2 out in front, so there's the 2. Then this n, which gives me a 20. Then this is going to be 20 plus 1, I think I'll just write it in like that, so 20 plus 1, and then this last one would be 2 times 20 plus 1. And then finally the last one would be 9 times 20, and again times 20 plus 1. Now if you put each one of these things on a calculator at this point and add them up, this one will turn out to be 88,200. This one will turn out to be 34,440. And finally, this last one will turn out to be 3,780. So 3,780. And if you add those all up, you will have 126,420. And that's going to be the final answer. So just a reminder, once you've, first of all, fold it, spread it all out, you can get the single expression. Then split it up into 3 different summations. Bring the constant out in front. Then the I cubed turns into this, the I squared turns into this, and the I turns into this. Then in place of n, put what n is equal to, which is 20. You can stick these individual ones on a calculator, get 3 separate terms, add them together. So there's a couple of summation notation examples for you.